Alrighty. I'll start the session in just a second. Just gonna get some water here. So you guys just took your first test. From the looks of the group chat, it looks like it went well. I saw some A's, some B's. I'm guessing that that's going to be skewed though, because people that didn't do well probably don't want to publicize that. But good job, regardless. Okay, got two people. Neat. So, last test, the last thing you covered was probably the chain rule. So this test, we're going to get into an application of the chain rule, which is called implicit differentiation. Actually, you know what? I'm going to use black for titles. Just kidding, that was unfortunate. So the chain rule says that the derivative for f of g of x is equal to f prime of g of x times g prime of x. So this rule can be taken a step further. Let's say we have a function like we've got, let's start with an easy one. Gosh, gotta test these markers first. So let's say we got something like y equals x squared. So that's a real easy derivative to take. So the tricky part is now that we've got this y term, so if we want to take the derivative, we have to differentiate the entire expression. So if you think about this, we can say we've got, okay, the derivative of y is 1, and then times dy dx equals 2x. So that gives us dy dx equals 2x. So the derivative of y for the function x squared, which is a function of y expressed in terms of x, we can also differentiate the other side. So this is a very basic example. And this, this checks out, right? Because this is the same thing here as writing like y prime equals 2x. So you guys are probably like, okay, cool. What does that mean? But you guys are going to learn this thing pretty soon called logarithmic differentiation, which will make the product rule, the quotient rule, the chain rule, it will pretty much make your life 10,000 times easier. And it will work every single time for a lot of problems. So now, this is a very basic example. We can call this example 1 here. So if we wanted to do something more interesting, well, why ask me when there's a textbook full of problems that we can choose from? because there are going to be examples here of more complex situations in which you're going to have to take the y derivative, but we're just going to take it nice and slow today because I know you guys had a test last week. So I'm just going to introduce this at a nice casual pace. We'll do a conceptual session today, and if we do a session on Sunday, it will be more of the problems, but today we're just going to go over some bigger picture concepts with the new material that we will be learning in this unit. So another thing that we'll be looking at is higher order derivatives. But really, what we want to do here is find something that's got a lot of terms of y that'll make it kind of messy. Here we go, here's a good one. So let's start with, I'll do example 2 in purple. So for this problem right here, what we're going to write down is x times y squared plus y times x squared is equal to 2. So we want to find the derivative of this expression, of this equation that we're given. So taking implicit derivatives and taking explicit derivatives, and an explicit derivative is just taking the derivative in terms of one variable. Implicit differentiation means that we can leave a few variables up for subtlety. It's more for algebraic purposes than anything, but it's the same rules essentially. So if we've got a term like y squared, since we're only taking derivatives in terms of x, the way we would have to write this is we'd have to do a chain rule. So we can view this y squared, we can view this as the outside here. So the next step would be, and I'm going to do an arrow because I don't want you guys to think that they're equivalent. So then that's going to be 2 times y, because we're just doing the power rule right there. But then we need to multiply by the derivative of the inside, which is just going to be our y term here. So the derivative of y is going to give us dy dx. And this is how, basically, this is how you should approach implicit differentiation. When you're differentiating, step 1, I would say, is, here, let me get a black marker. I just cleaned everything in my apartment, so now I know where everything is. And I happen to have a black marker in my bag. So with implicit differentiation, for a problem like this, our first step, we'll say step 1, is going to be take the derivative. Our first step is going to be to take the derivative of the entire equation. So the way we're going to do this is we're going to look at each term in here. So I see 3 terms that we can work with. This one right here is the product of 2 terms, so we're going to have to do the product rule for that. So I'm going to write this out just because this is my kitten. Here you guys go, just for showing up. There's a little kitten for you in case you're having a bad day. So the next thing we're going to do is the product rule, which if we've got f of x equals x, g of x equals y squared, and you guys should remember the product rule because I'm sure you used it a lot on your test. So this is going to look like this. F of x times g prime of x, which is going to be 2 y dy dx. And then plus f prime of x, which is just going to be 1. So 1 times g of x, which is y squared. So that's going to give us x times 2y dy dx plus y squared. And that is the derivative. This right here is equal to dx of x, y squared. So is there any questions on just that part right there? This right here, is there any questions on how that was done? This is just an implicit solution, meaning that we did not solve for dy dx, but the reason I have not solved for dy dx yet is because this right here is only the derivative of one portion of the answer, which is this unit right here. So now, as you can imagine, we're probably going to do something very similar for the next part, which is just y times x squared. And that's correct. We will be doing the product rule once again, but you got to be careful with these values here and make sure they don't confuse you. So this is the second derivative, which is right here. The way we're going to do that is we're going to say, and I'm just writing all the steps out for y'all just in case anyone needs me to slow it down. I figure this way I don't have to go back and rework stuff. So f of x equals y, g of x equals x squared. So then f prime of x equals dy dx. And that's basically just how we write the derivative of y in terms of x there. And then we're going to say that g prime of x is equal to 2 times x. So if you remember the product rule, I'm going to move this kitten. If you remember the product rule, it is, I'm just going to write it out just for fun, f of x times g prime of x plus f prime of x times g of x. And that is how you take the derivative of, for the product of two expressions, two equations, two polynomials, my bad. Looking for the right terminology there. So now we're going to write the derivative for that expression is y times g prime of x, which is 2x, plus f prime of x, which is dy dx, times g of x, which is just x squared. So this is equal to y, the derivative, d dx, for y times x squared. And that is the second portion of this problem. And remember, this is just the same thing we've been doing, but the only rule now is that essentially we're taking the derivative of a y term, which means that we have to apply the chain rule to it, which is why whenever you see me take the derivative of a y term, I always do dy dx. So are there any questions on this portion right here? I'm just going to give some time because the next part's real easy. And then the part after that's kind of tricky. So if you've got any questions, now's the time to do it. I'll give you guys a little bit of time here so I can drink some water. I'm I'm just going to erase example 1 here and this stuff on the side of the board so we got more room to finish the problem we are currently working on. There we go, look at that. All right, nice and center. So no questions? Just type no, yes. If you have a question, type it. If you don't, just say no, so I can move on, make sure that no one's waiting here if you don't have a question. No, could use another example later. Absolutely, I plan on doing a few. This is my favorite unit. So d dx for, let's just start with xy squared is equal to x times 2y dy dx plus y squared. Then we also know that the derivative for, what is our second term here? Yx squared is equal to 2xy plus dy dx times x squared. So we know that we've got this bit right here and this bit right here, and that translates to this and this. These are the derivatives. This right here is the derivative for that one, for that polynomial, and this is the derivative for that polynomial. We did both of those by using the product rule. So now, the next one, I guess, since we got to do the whole equation, the derivative of 2, the derivative of constant is, of course, always equal to 0. So now we have 3 separate things that we can plug in for the current 3 things. So we have the derivative of all of the terms in the equation. So let's plug them in so we can get the equation for y prime. So what this is going to give us is x times 2y dy dx plus y squared plus 2xy plus dy dx x squared is equal to 0. So this part I said was going to be a little bit tricky, but if you're pretty swifty with your algebra and you know your stuff, you know how to add and subtract like terms, and you know how to factor stuff, this should be a breeze to solve from here. And the objective here is to isolate dy dx. So I'm just going to go ahead and start working this. Our first step is going to be to get rid of all terms that do not have a dy dx. So I'm going to go ahead and subtract the y squared and also subtract this 2xy. And what you do on one side of the equation, you have to do on the other. So we're also going to subtract it on that side. And what that's going to leave us with is x times 2y dy dx plus x squared dy dx is equal to negative y squared minus 2 times x y. So right here, you're probably like, okay, what next? But if you remember how to factor, then you should know exactly what to do next. What we're going to do here is we're going to take out the dy dx. So we're going to put that out in front, dy dx times 2xy plus x squared equals negative y squared minus 2xy. So now the final step for this, and I'm going to finish this equation up here because this is the last part of the whiteboard that's going to have room. So the final part is to divide both sides of the equation by the non-dy dx term, which should give us the answer. We'll get dy dx is equal to, and I'm just going to factor out this negative y here as well, just so the math looks nice and pretty, is equal to negative y times y plus 2x divided by 2xy plus x squared. And this is going to be our final answer. So that was a lot, I'm not gonna lie. And it doesn't help that we have a small whiteboard here, but if you have any questions, I'm gonna now go ahead and give you some time to type them up because I want you guys to really understand this content. This is some pretty tricky stuff. Even, let me give you an example of how tricky this stuff is. So I did a math bowl for Kennesaw, and one of the questions was this really long, disgusting derivative. And you guys can type your questions while I'm going on my little monologue here. But it was this really nasty, disgusting derivative. And like everyone was spending such a long time on it. So I just decided to set it up as y equals that. And then I use logarithmic differentiation, which I'll introduce at the end of this session. But I multiplied on both sides and everything, and I showed him my work and he said it wasn't right. So he said I can't do that. And I thought that I just wasn't allowed to use logarithmic differentiation, which I thought was a weird rule. But then after the math ball, I ended up getting third. This was like 2 years ago. After the math ball, I went up to the judge and asked him about it. And he realized that he didn't recognize I was using logarithmic differentiation because that's not something that a lot of people use frequently. And like, I showed him my work and all of that. And, you know, I didn't care about the placement or anything like that, but it was just, you know, even someone that's been doing math for their entire life can forget stuff like this. Like, this is really just obscure stuff that you probably won't use again unless you're an engineer or a math major or a computer science major, something like that. But if you're doing a STEM field, I mean, you should know how to do a derivative, and this is one of the most efficient ways to take a derivative. With implicit differentiation, you'll get a lot into this in Calc 3 as well as differential equations, which if you're here and you think you want to be an engineer, you do have to take differential equations. So I don't see any questions in the chat. I'm just going to go ahead and erase this and then work another problem. And then I'll do one that's a little bit shorter than that, just so we have more. Or I'll just erase all of this and write neater, sort my work a little bit better. Because now you guys have a general idea of what's going on. So for this next problem, if you have pen and paper available, I would like to request that you work the problem. I'm going to write it down, and then I'm going to start working it very slowly just so every step is shown. But I would suggest that if you are thinking that you're quite good at taking derivatives, to go ahead and work ahead on me, and then kind of use this as a benchmark of where you are with implicit differentiation. So I'm going to go ahead and work another problem now. Let's see. Okay, so this one's fairly in here. So for this problem, we've got 4xy is equal to x squared plus y squared. So like I said, if you think you kind of got the hang of this, go ahead and start working ahead of me. I'm going to leave it up for just another few seconds here, and then I'm going to start explaining and working. Alrighty, so the first step, like I said last time, is we want to find the derivative of the entire equation. So we're taking the d dx for 4xy equals x squared plus y squared. So we want to take the derivative of all of that. Now, constants can be annoying. So what we're going to have to do here is we're going to take the derivative of 4xy, x squared, and y squared. And then we're going to plug back in those derivatives and solve for the term dy dx. Because we want to isolate that by factoring, and we'll get into that in a minute. First, let's just take a look at the problem. So for derivatives, I'm sure you guys remember some rule like this, like d dx for c times some polynomial is equal to c times d dx of the polynomial. The constant isn't affected by the derivative. So we're going to take that 4 out of the way, and then this is x times y. We're going to use the product rule. So x, y, we're going to say that this is f of x, this is g of x. So now what we're going to do is we're going to say, we're going to map this out a little bit more clearly. So we've got f of x equals x, g of x equals y, then f prime of x equals 1, and g prime of x equals dy dx. So now all we have to do is plug into the product rule, which I'm going to reiterate it because I did want to give anyone that's feeling adventurous a chance to try these problems while I'm explaining. So the product rule, and I'm just reiterating this because honestly, this is definitely something that's worth memorizing. There's not a whole lot of things you actually need to remember in math. And when I say not a whole lot of things you actually need to remember, I mean like blatant memorization. Like you don't need to blatantly memorize a lot of stuff for this class. But a few of these theorems are worth just having in that toolbox upstairs. So now let's plug in. We got f of x is x times g prime of x, which is dy dx, plus f prime of x, which is 1, times g of x, which is y. So that's going to give us x dy dx plus y is equal to the derivative of xy. So now we're just going to go ahead and plug that back in, and we're going to put that in our parentheses here because I got the 4 out front, because remember this is just a constant, so it doesn't affect the derivative. So there is the first part of our derivative. The second part is going to be x squared. So lucky for us, that's quite an easy one to take. So d dx for x squared is equal to 2x. We're just going to go ahead and plug that into the formula here as well. So then the next one we're going to do is d dx of y squared, which is just going to be equal to 2y. We take the derivative on the outside, then we have to do chain rule and take the derivative on the inside. So then this is going to be plus 2y dy dx. And this right here is the derivative of our initial statement here. But we're not happy with this. This is an implicit solution. It is implicit differentiation, but we want an explicit solution. We want our solution in terms of dy dx. So luckily, there's not much else we have to do. We just have to do some basic algebra. So the first thing I'm going to do is distribute this 4, which is going to give us 4x dy dx plus 4y is equal to 2x plus 2y dy dx. So now the next thing we're going to want to do is we're going to want to group like terms. So I'm going to subtract this 2y dy dx from both sides, and then I'm also going to want to move this 4y over to the other side. So we're moving this here. I'll draw the arrow, and then we're moving this over here. And the reason we're doing that is so that we can get our equation in the final form of 4x dy dx minus 2y dy dx is equal to 2x minus 4y. And from here, our problem is rather easy to solve. The first thing we're going to do, obviously, is factor out this. So we're going to do, that's going to bring us down to here, dy dx times 4x minus 2y is equal to 2x minus 4y. And then all we simply have to do is divide both sides by this term right here, 4x minus 2y. Which brings us up here. And that gives us, I'm just going to write it nice and big because I can. Dy dx is equal to 2x minus 4y divided by 4x minus 2y. And we can simplify this further, actually, because I don't like to be lazy. So factor out the 2 from the top and the bottom. That cancels there. X minus 2y, 2x minus y. So our final answer is going to be x minus 2y over 2x minus y. If you have a question, now is the time for it. You should at least have a basic idea of what's going on by now. This should look very similar. I'm going to give you guys a few minutes to ask questions. If you don't want to type it in the YouTube thing, you can do it in the group chat too. All right. No questions? If you don't have questions too, you can just say no. That will save prolonged periods of silence. All right. Well, I guess you guys get it pretty well then. Okay, Now, this one, I actually do have a question. Is this something that you guys have started in class yet? Is this something that at least looks familiar, or is this the first time you've ever seen this in your life? This is something we've seen in class. Okay, good, good. Then it shouldn't be terrifying. What is it that everyone doesn't like? Is it trig functions? Is it fractions, radicals, that stuff? Let's see if we can find a fun one. Okay, here we go. So I want the really, really good, the people that are really good at math and like the really eager ones, like the ones that like are planning on majoring in math and stuff like that. I want you guys to go ahead and give this one a go. I'm gonna work it, but actually, you know what? Before you even start this, I'm gonna ask a question. So don't write the question down, but don't start working yet. Okay, so who thinks that this derivative would be easy to do, like very quick? Just say yes or no. Say yes if you think it would be quick to do, say no if you think it would be slow. No, right? Because this, yeah. I mean, like, look at this thing. It's a nightmare. Like, we got a radical in there, we got a product rule, we got a quotient rule, we got a chain rule, another chain rule because of the radical. That does not look like fun at all. That looks like something to be very time consuming. So, oh, what did I draw? That was my cell phone. Okay. I'm going to show you guys how to not waste time. So first, let's just take the natural log of the whole function. We can do this, by the way. This is okay in math. Yeah, this is where you're going to start seeing things that are more interesting than high school algebra. So you guys are probably like, okay, that's neat, but what does that mean for us? But the real question is, there's not a real question. I don't know what I'm doing, what I was going for there, but I'm alluding to something because this is going to be pretty fantastic. So check this out. So if you guys remember your log properties, then you should recognize some stuff here. Natural log of x squared plus natural log square root 5x plus 1 minus natural log 3x minus 2 cubed. Oh yeah, that's right. High school algebra, it's coming in use now. So if you were one of those kids that said, when am I ever going to use this in life? It's pay time. It's time to pay the teller. So let me show you some neat tricks now that you may or may not remember. So first of all, I'm going to get rid of the square root. This one should be very familiar. And I'm just going to change that to a 1/2 power. And the reason I'm doing that is because for logs, we can just move the power of these things out front. So we get natural log of y equals 2 ln of x plus 1/2 ln of 5x plus 1 minus 3 ln of 3x minus 2. Yeah. So this is, you're probably like, okay, I don't like natural logs either, but the one real cool thing about a natural log, y'all, is this right here. So if we got, like, let's take a derivative one, right? Derivative of ln of x is equal to 1 over x, right? Yeah, for any linear function, it's just going to be the reciprocal function of that linear function, which takes us to my next point. So that's going to give us, and don't forget, we have a y here. So this is an important detail right here. So now we've got 1 over y times dy dx is equal to, and I'm just differentiating as I go. Tell me if you need me to slow down. Is equal to 2 over x plus 1 over 2 times 5x plus 1 minus 3 over 3x minus 2. Yeah, so this isn't going to be a long, horrible problem. Now let's investigate even closer, because I don't know, the numbers look kind of gross. If you really want to, I guess you could put it all on a common denominator, but you don't have to, because check this out. So we've got 1 over y times dy dx equals all of this. So now we're going to multiply y on both sides, right? So now we got to multiply this whole thing by y. But this is the part that every Calc 1 student forgets, and I can say that because I was a Calc 1 student at one time as well, and I did the same mistake, and it was a 15-point question, and I just left this as my final answer. Like, and he didn't even care about this part. It was like, I simplified the denominator because I'm OCD on tests, but I just left that, and I was like, yeah, that's correct. But you have to plug back in the initial equation right here. You got to plug it back in. So our final answer is this. dy dx is equal to the product of our initial equation, which is x squared times the square root of 5x plus 1 over 3x minus 2 cubed times 2 over x plus 1 over 10x plus 2 minus 3 over 3x minus 2. Yeah, no product rule or anything. How about that? Okay. If that made sense, say yes. If it didn't, say no. All right. Everyone else able to follow? I want at least like 2 yeses for this one because, oh, nice. All right, I like this. You guys are putting in work. All right, learning math. Let's do some more. Remember, the only time you really want to use logarithmic differentiation is if you're feeling lazy. Like, because most derivatives, if it's an easy, quick one, it's not going to be faster to use logarithmic differentiation. And if it requires more than one step, like you have to take the second or third derivative, also wouldn't recommend starting with logarithmic differentiation. I mean, I'm sure it would work. Well, it definitely would numerically, but it would be very hard to keep track of. Okay, let's see what else we got in this one. This is like, I don't know, they make this like the scariest part of calculus, but then you take calculus 2 and you look back on this and you're like, that wasn't that bad. Alrighty, so, oh, this is something you guys like to do. You guys like to find the tangent line at a point, don't you? Well, don't worry, I'm getting there. So let's do this. Y equals x times the square root of x squared plus 3 divided by 1 plus x. Nice. At the point 1 comma 1. Alrighty. So I don't want to take the derivative of that. I'm feeling lazy. Oh, can you explain how the natural log changed to y times 1 over y? dy dx. I missed that. So ln of y, so derivative. Well, here, I'll start with ln of x is equal to 1 over x, right? But if we take the derivative dx, we're taking in terms of x for ln of y, then that's going to be chain rule. So it's going to be 1 over y times the derivative of y. We have to take the derivative of the outside and multiply it by the derivative of the inside. It's the same concept as regular derivatives, but you have to put a dy dx whenever you do anything with a y in it. Good question. Alrighty, taking the derivative and getting a tangent line. So let's do that. Let's take the natural log of both sides, because that looks like a nightmare to take the derivative of. And I'm thinking that we're probably getting close to that time. So this is going to be the last problem we're going to work. So now we're going to take the derivative of all of that. And I'm put all of this in parentheses because after we apply all the log rules, we do have to take the derivative of it. So the derivative for ln of x is just 1 over x plus 1/2 times 1 over x squared plus 3 times 2x, because we have to take the derivative of the inside as well. That's going to cancel. So that's going to give us 1 over x plus x over x squared plus 3. Then we're going to take the derivative of this one as well, which is going to be minus 1 over 1 plus x. And this is all equal to 1 over y times dy dx. So now we multiply both sides by y. And remember, y is equal to that. So our derivative for this is going to be equal to is equal to 1 over x plus x over x squared plus 3 minus 1 over 1 plus x, all times x times the square root of x squared plus 3 over 1 plus x. And we were given a 0.11, so our next goal is going to be to plug in that 1. So I'm going to go grab my calculator so we don't have to simplify all that. And again, guys, if you have a 4-function calculator, which I'm pretty sure is all, or a TI-30 variation, you should very easily be able to type that in. So we're just going to plug in 1 for all the x values, and I'll write it out too, just because that'll probably be a little easier to see. So 1 plus 1 plus 1 over 1 plus 3 minus 1 over 1 plus 1 times 1 times the square root of 1 plus 3 over 1 plus 1. So you guys, math is just addition and subtraction at the end of the day. 1 plus 1 over 4 minus 1 over 2 times square root of 4 is 2 over 2. So that's just 1. So we've got 1 plus 1 over 4 minus 1 over 2. And that's going to give us 3/4 minus 1/2 is equal to, wait, just kidding. Plus 7 5, 7 3/4. Yeah, I said the answer, but I misspoke. There we go. So this is the slope of the tangent line right here. So now all we have to do is y equals mx plus b. So we're just going to plug in our y value, which is 1 equals 3 over 4 times 1 plus b. So we get 1 equals 3 over 4 plus b. So thus b is equal to 1 over 4. And our tangent line at that point is going to give us y equals 3 over 4x plus 1 over 4. Alrighty. I think that's about all the time we've got for today. I'll leave it on for just a second in case any of you are typing a question. But yeah, that is our intro to logarithmic differentiation. Ooh, right on the money. That was from the textbook, and we literally got that problem perfectly right. And the textbook closed before I got to work any of it. So that's how you know when you're getting good, guys, when you can just open up a textbook problem, choose the hardest one, and solve it. That's a good metric of when you can start feeling confident going into a calc test. Is there any questions on the techniques taught today or anything that was covered today? I'm just going to leave it on for a few minutes just in case anyone wants to type or write something down. But this is the end of the session for today. I'm just going to leave it on for some questions. And also, since I'm not going to be doing anything, I'm just going to graph this for you guys while you're typing questions and stuff, just in case anyone's curious, because I certainly am. And we're going to divide this. I mean, look at that. That's so cool. Like, all that math led us to one linear equation, and there's no gross numbers or anything. Oh yeah, that's real cool. So I know you guys probably are gonna have a hard time seeing this, but this right here is what the graph looked like. So it was like I'll do a rough sketch. And after I sketch this graph, I'm done because I don't know. It's probably not good to just sit here and talk to that YouTube screen for more than an hour at a time. So I'm gonna erase all of this. And I'm just doing a rough sketch of the graph just so you guys can kind of get an idea of what that would look like. Because it was a really complicated looking graph, actually. There's a big old asymptote in both the X and Y quadrant from the look of it. Yeah, it looks something like this. Other one is like, and then our line, which was, let's see, there, was something like that. And this is a poorly drawn line, but this was our derivative, which is y equals 3 over 4x plus 1 over 4. So pretend that my line's a little better, but that is the line in which it intersects, in which it is tangent at that point. So no one's typed any questions or anything, so I'm gonna take it that that means that I probably did a pretty good job and you guys know your stuff. I'll just take this as a win that there aren't any questions, and I'll take it in stride. So thanks for coming, y'all. I hope that this was helpful. I mean, I thought that logarithmic differentiation was like magic the first time I saw it, because after doing the quotient rule and the product rule for so long, it just was like, wow, that is nice. I don't have to do anything. I just have to do algebra. And, you know, it's handy when it's handy, but sometimes there's a time and place for it. And the more problems that you do, you're going to end up seeing when it's the appropriate time to use which technique of derivation. And that's the basis of higher level math. It's not something that you can just repeat until it's dead. Like, you need to understand these concepts well, otherwise you're gonna have a hard time moving on to the next course, which is Calc 2, because it's the exact same thing. It's just learning when to apply certain techniques to certain situations. The more I am not discouraging repetition, because the more you see it, the more used to it you're gonna get, but not if you're just going through the motions or doing like Symbolab or something like that. You guys, like, if you just sit down and work through a couple of these problems, you'll start learning some pretty cool tricks. Like, this is a very interesting course, and I mean, I know that math isn't everyone's favorite subject, but I hope that you guys are at least learning to think like a mathematician while taking this course, because I think that it's just a very important aspect of learning as in general. It's critical thinking on steroids, really. But that's all I got for today, guys. So I'll see you around next time.